Good morning, good afternoon, good evening, wherever you are. So happy to have you with us, and very happy on my side to have the opportunity to discuss with Benoit, as mentioned, CEO of Aerospacelab. So before maybe we jump into the discussion around Constellation, Megafactory concept and all things shall change moving forward. Benoit, could you maybe just give an update, some views on Aerospacelab this year and some milestones or initiatives?
Yeah. First of all, thank you. Good afternoon, Pacome, and happy to be here. Glad to join this webinar. Yeah, we reached 75 employees, a little bit more after 3 years after the inception of the company, and we achieved quite a huge milestone for us this summer by having our first satellite being launched with SpaceX, and it's working nominally. So we are quite happy with that.
That's quite an achievement for sure, and long-awaited moment always for the teams working on it. Okay, so maybe as we get closer to today's topic, so obviously the industry has been a lot about constellations, various sizes, various application in this new space environment, more assets at a lower cost. So can you give us your view of that constellation dynamics and change in the ecosystem that you see resulting from this trend?
Yeah, I mean, it's quite unbelievable. Like 5-10 years ago, who would have imagined that constellation in the range of tens or even tens of thousands of satellites would be, I would say, daily business now. I mean, the most famous one like Starlink, Kuiper, OneWeb, Lightspeed, and the others. Now it's kind of a new normal to have like a mega constellation being not only announced but financed, well financed for some of them, and even put into space. So there's definitely a trend going on there, which is rather new and linked with, I would believe, the launch offering and the launcher development dynamic that we can see evolving alongside the constellation trend.
And you've been obviously involved in the geointelligence business. So as you mentioned, I mean, they are the so-called mega constellation of the thousands to dozens of thousands of satellites potentially. So together with that, there is obviously a number, to say the least, of constellations in remote sensing, IoT, other applications. So which tends to be, let's say, at least at the initial stage in the dozens to maybe couple of hundred of assets. So do you see those concepts of constellations growing, maybe in stages or in steps? Because there is a kind of mega part, and there is a, let's say, other constellations part as it develops in the market.
Yeah, I believe it's quite interesting to notice that most of the first wave of mega constellation, if not all of them, were telecommunication constellation, so broadband for most of them. And I believe that this comes from the fact that maybe this industry is maybe more mature than commercial remote sensing, at least for B2C or B2B customers. And if I'm not wrong, the World Satellite Business Week, from its inception up to recently, was mostly focused on telcos. And it's very natural for them to be able to finance such large capex projects, being a more mature industry. But as you mentioned, I believe that with maturity and market education, it's only a matter of time before IoT and remote sensing in the wide sense may pick up this trend as well.
Thanks. And obviously coming even closer to the topic of today. So those constellations, all of them need to get built, which has come through a variety of strategy actually from models, some of them purely vertically integrated to fully outsourced, so a mix of both across the entire space industry. So our topic today is about the Megafactory concept and how it could play in Europe. So maybe just the starting point would be about defining what a Megafactory can mean for the satellite industry. what kind of what volume or whatever is correspond to what a megafactory has to do to be, to exist and build.
Yeah, so yeah, it's quite an interesting question, because I don't believe there are such a consensus on what defines a megafactory out there. But my personal definition would be something along the line of at least one web generation, one manufacturing throughput. So roughly speaking, 2 satellites per day would be a nice entry, like ballpark figure about the throughput we envision for megafactory class infrastructure. But it's mostly, I believe, in the processes, in the way the satellites are being built. So it's really a structural shift from unmade, very expensive, I would say, prototypes or quasi-prototypes, up to what could look like mass manufacturing automobile assembly line. And this is more not only linked with the throughput, but more with the way the industrial setup is being set into motion.
So, and I assume it comes on the one side with, obviously, I mean, it's processed even for the manufacturing itself, but it also calls for even increasing standardization of the onboard equipment of series of equipment that will adapt whatever number of missions. So it's kind of the two things working together.
As you mentioned during the introduction, we have a lot of different models out there, vertical integration up to fully outsourced and all the spectrum in between. There are also other, I would say, degrees of freedom in terms of modularity, standardization. We see that the first gen of mega constellation, the mega factory that is producing those space assets is usually optimized so much towards this specific satellite series production that in the end, flexibility was not really optimized for the first generation of mega factory. And this is something that we want to improve upon for our plans.
And for the mega factory concept, and coming back to what you mentioned, let's say notionally at least a couple of satellites a day, and then volumes depending. So the example you took was OneWeb. So as can happen in space project, and there can be the short and the long-term situation, but having such volume, I mean, does it require to have an anchor tenant or anchor customer? So obviously OneWeb and OneWeb satellites got developed quite in parallel, let's say, even if they separated the entities. So yeah, there can be the more vertically integrated model, but do you need essentially a constellation of whatever hundreds or thousands of satellites to just make it happen, having such anchor clients, or do you think it can be built through whatever a variety of clients that would come to the production line?
Yeah, I would say first that I don't have like specific talent to forecast the future, and I believe that it's open. There's a bit of uncertainty in this market, and that as you mentioned, the first generation of mega factory setups that we can find out there, OneWeb, Starlink, and the others, they were built around this anchor customer and not the other way around. So they didn't build the OneWeb Florida plant waiting for OneWeb to solicitate them. So the first gen is really the cause and effect, the causality link is in that direction. We don't know yet if we can sustain like building the plant and waiting for customer to join and to generate the commercial traction. In our specific case, I would say that it doesn't matter that much because we anticipate to be our first anchor customer ourselves with our remote sensing constellation. So we can delay a bit the answer to this question and reduce the risk by putting the emphasis on the modularity and flexibility. So the idea is to manufacture a couple of hundreds of satellites per year, but more importantly, to be able to focus on customers that would be requesting low tens or low hundreds of the same satellites, and be able to reconfigure the assembly line to service those customers.
Okay, and I think thinking of such customer mixes, and I assume obviously that you could be in a position to deliver satellites in a faster way, meaning even if you have a series of dozens, development time could be reduced, assuming obviously this is very full yet. So I assume serving a diversity of clients, the platform part, maybe the one that you can, let's say, where you can develop a process, maybe in the easiest way, easiest being a big word, really, or several platforms, but then isn't the payload the more difficult part, especially if you have several missions and obviously this being designed and the components and the partners and supply chain to organize there. So do you think on the payload part, obviously if you have series of, okay, make me 100 with exactly the same payloads once defined that can work, but it's where you could need the most adaptations in the production line to different clients and the payload portion of the satellite.
Yes, indeed. So what we see now with the customers or potential customers that are reaching out to us is that usually they build their business and their strategy around the payload, and they consider the satellite bus or platform as a commodity now. So the trick there, as you mentioned, is to design a platform that would be versatile enough to cope with non-defined payload or payload that we don't know yet, in such a way that we can reduce non-recurring engineering activities to the maximum, and this to allow commercial pricing, but also, and more importantly, I believe, aggressive lead times, because new space, even though I'm not a huge fan of the name itself, it's built around agility and iterative development, and we cannot afford long non-recurring engineering activities, and we have to have like incremental prototypes and so on. So this is really the key aspect, is to make sure that the platform is versatile enough so we can cope with a lot of unknowns in terms of payload interface. Most obvious one are, I would say, volume, mass, but there are a lot of tricky ones. Thermal management of some fancy payload may require a thermal architecture of the whole satellite that is fairly tricky to get by. So we are working on that, and what we tend to push forward is to sacrifice a bit the mass to push forward the modularity and the flexibility. So if you optimize your satellite for mass, as it was the main driver for the past few decades, it's really difficult to have margins everywhere to cope with uncertainty on the payload side. But if you throw mass at your problem, you may be able to find a technical solution on the satellite bus that will translate now into a couple of tens of thousands or hundreds of thousands of euros of extra launch cost, which is somehow not significant anymore compared to the total cost of ownership of the mission.
Okay, yeah, that makes sense. And in terms of the sources of demand for Constellation and Megafactory, so actually when we look at the industry, which is to a certain extent I'm not saying the opposite to the industry history, but admittedly, most of the, let's say, constellations, large ones, are privately financed or private initiative today, as opposed to government clients who maybe, I mean, we can see DARPA in the US also. So there are initiatives to look at smaller satellites in some places, but in terms of volumes or constellations, so far demand has been more from the private sector. Do you expect the demand to grow both sides and to see, let's say, institutional clients, whether civilian or defense, to come on board? I mean, we're obviously aware about the European initiative, so to say, at this stage, but outside of this specific one, do you see the kind of new space concept or institutional demand also growing? And where as well, having as the topic of today is Megafactory, but also European Megafactory, do you think that localization of some of the production for also government requirements will be important moving forward?
Yeah, I mean, commercial market was the first to experiment with this kind of concept. because agility is often agility and innovation is easier to implement in commercial businesses. There's a lot less red tapes than in agencies and commercial and governmental customers. But in the end, I mean, if this new model of distributed systems in orbit, so instead of having monolithic space segments, you have like distributed constellations, bring some value to the services. It's only a matter of time before institutional customers and agencies will adapt some of their mission to this new concept as well. So as you mentioned, we see the European Commission moving into that direction with the Secure Connectivity Initiative. It's not totally crazy to think about some remote sensing mission under the Copernicus program that are now served by a couple of heavy satellites being complemented or replaced in the future by small constellations of a few tens of satellites to increase revisit and other metrics. So I believe that the institutional customers are following carefully and learning maybe from the mistakes from, if any, from the commercial customer that were the first adopter for this.
Thanks. I see some first question to our delegates. So may jump on one on. So I mean, you mentioned about obviously the fact to have a flexible platform or the ability to accommodate a variety of missions. So the question is a bit about, okay, if you don't know the missions in advance, let's say, or at least a good sample of the payloads you could need to embark. So you know, what's the current development stage, and how do you manage the sizing or level of flexibility? As you would mention, it's kind of a trade-off between flexibility in what you can develop and the complexity of the process. So.
Yeah, that's quite a huge question on its own. But basically, what we did is we started with I would say passive electro-optic remote sensing mission. So basically, visible range and shortwave infrared range telescopes, and we started to do phase 0 NA on different mission concepts and payload concepts, and then we started to see that between high res, so submetric and even like 50 centimeter and below. Centimeter imager with agility constraints and microvibration requirements that are fairly harsh. And then on the other hand, multispectral missions that are doing nadir automatic collection of data with relaxed ground sampling distance, such as like 10, 20 meters. We see that there are subsets of requirements that are overlapping, some others that are included one into another. So if you design a platform and you can fulfill one, automatically you fulfill the other. And then more interestingly, in terms of system engineering challenge, you have requirements that are mutually exclusive as well. So we did the job to push into understanding what would be the main design drivers for most of the payload category we can think of now. So ranging from synthetic aperture radar in different bands up to 50 centimeter pan imagers. And we are starting to do so with specific telecommunication payload as well. And we did this activity with potential customers, with payload manufacturers, to try to see where it makes sense to design a payload that would encompass all of those requirements, and where it would make sense to do a fork and to do, I would say, a spin-off of the satellite bus that we have, to be reworked for this specific family of payload. So I could speak about that hours, and I would suggest that people asking the question to reach out to me. But that's a bit the system engineering approach that we developed.
Jumping on or rebounding on our previous questions, I think if you think of how the industry got organized around geostationary satellites and the rest, I think over the years we saw that either depending on the design of the launch solutions or the satellite platforms themselves, obviously standards went to a form of standard, at least platform related, where project orders would design partly their payload and everything in order to fit with those, let's say, existing products. Thinking of small satellites is still relatively early stage, especially constellation-wise. whereby obviously with the Megafactory concept or plants and some companies being vertically integrated, we may not be at this stage yet. So especially with high manufacturing capabilities, large volume, would you expect kind of the same to happen with the form of standardization of platform products around which a new project order would work in order just to leverage existing process, production capability, and cost efficiency, I believe?
Yeah, I'm a bit young to be aware about the geostationary history, because it was still going strong. It was already going strong when I was a small child. But I believe that the geosatcom market, as you said, evolved in a closed loop feedback between the launcher's design and the geosat designs, and they were kind of a 1-1 match. So most of the geo missions were like one launcher, one satellite, one customer, and we are going more and more into the rideshare opportunities, where I believe it's not, the feedback loop is not symmetric. It's more like big launch providers are kind of setting the scene for us, and we have to comply with their design rules and cost drivers, so we can have efficient end-to-end missions. So the idea is really for us to keep the agility and make sure that the platform we design with standardization in mind, modularity and flexibility, can cope with the existing launchers and future ones.
Yeah, well, I think that makes sense. At the same time, so let's assume I'm a new startup or whatever company interested in a new constellation. We are 2025 or 6, and I come and say, okay, I want to do something new with that type of capability or payload. I assume from early stage or design, I could want to approach or work with companies having a Megafactory also to say, okay, let's give me kind of your existing products or specs that I can take that into account in the design of what I plan to do, just to take the most efficient approach. And maybe I will work on my payload, but okay, these are options for platforms that I can consider for my satellites, as opposed to design something completely new and not necessarily optimized for the existing factories or plants by that time. That would make sense, I believe, to have that kind of co-development for the future concepts within a few years.
Yeah, indeed. I mean, most of the constellations in LEO are sharing a lot of common needs, maybe like orbital planes, and for most of them, they still go for remote sensing into sun-synchronous orbits. And for inclined orbits, we have some rideshare opportunities as well, and micro launchers playing their part of their role in this as well. So indeed, if I were a new company like in 2010-25, I would rather try to fit within the standardized value chain, from payload hosting capabilities up to ride shares, to minimize the cost, because my competitors might go in that direction as well.
Sounds good. So coming back to the question of the demand dynamics, so we've touched on that already, but taking the situation of fundraising or what has changed, and just looking at the last year, so obviously a number of companies have looked at various opportunities, but including those SPACs that have been pretty high in the news. There's been other forms of fundraising, but overall, clearly a number of constellation projects have been given a boost in the last 3 years, including this year. So out of those, do you expect it to give a further boost to demand? Because, okay, cash was required to move on with various programs. Now cash is available to at least a number of them. So it's kind of a milestone being passed in those logic of round A, round B, up to deployment and then expansion of the fleets in orbit. So do you see that as a kind of game-changing year or couple of years from a financing standpoint? I mean, very true for Earth observation, but not only IoT and the rest.
Yeah, I believe that there was quite an influx in terms of funding in the last 18 months, accumulating with the SPACs that were announced, and some of them closed already. I believe that it was, kind of a spike that we need to see if the trend is confirmed, and more importantly, if the companies that raised a lot of money are going to deliver, because the rest of the market is looking at them, and they are kind of the canary in the coal mine now.
Yeah, I assume, and as you say, I mean, a number of concepts have been there. So now for a number of operational LEO, I mean, NGSO constellation, mostly LEO. Yeah, we see more companies having now satellites into orbit and services starting. So will be a form of delivery time for sure, and let's say test in real operations and commercial operations in the coming months will be critical. So coming back to Aerospacelab and thinking of the next 12, 18 months against and it was a bit the start of our discussion. What would you highlight or consider as major objective or milestones for you over that time period?
A lot of them. So the most obvious one is to really shift from prototyping to series production and start a ramp up of the series production. And this goes through a new exercise, because we have been dealing with R&D and prototypes for the first 3 years. And now we are learning that mass manufacturing is another skill set we need to acquire. So I would say that this may be our first major challenge in the next 12 to 18 months. And then we have, as we were mentioning before, commercial KPIs. So we need to strengthen our commercial sales and be less dependent, I would say, on institutional sales. So tilting the balance towards more commercial sales and less institutional sales relatively, while aggressively looking for signing contracts in both markets anyway.
Sounds like a plan, and it should keep you busy months to months. And I believe the entire team that has grown quite significantly in the last 2 years with the company. So, all right, that lead us to the end of this webinar session. So thanks a lot, Benoit, for sharing those insights. It's been much appreciated, and I'm sure by our audience through today and the options for reviewing that letter. So thanks again a lot on sharing this on the concept of Megafactory and impact in our industry. Thank you.
Thank you, Pacome, for hosting me. Bye-bye.